practice.
That sucks.
Yeah, but I mean, they can't not let her walk. Because she was in California, they took it. Or no, it wasn't. I think it was AP government, not AP English.
Yeah, it was Gov.
Oh, it was
It was. She planned that because it was the day that she got back. It was that Monday, so she was here, but she didn't want to.
Oh man, I would have just taken it.
Like, yeah, that sucks. All right, so did we get to try the practice problems last night? They go okay?
Yeah, I didn't do any homework last night. I did. You take them, not the most.
Do you have questions? Okay. We didn't get to look at the last differential equation problem yesterday. So I wanted to look at this one a little bit today because it's a differential equation problem, but it's a little bit disguised, I guess. So on this one, they give a differential equation as dw dt. I mean, pretty much everything we've looked at has been, dy dx. But here, we're saying this differential equation is dw dt, where this models the temperature inside a fridge. And at t equals 0, the temperature inside the fridge is 3 degrees. So this is an initial condition, and this is a differential equation. Even though it's not in terms of x's and y's, they could spring something like this on you. So we've got an initial condition, 0, 3, and a differential equation. So I really just wanted to look at B, I think, solving the differential equation. Because on these types of problems, solving the differential equation is more than half the points. Okay? It's usually either 5 or 6 points. So for B, we want to solve this differential equation. We got dw dt equals 3 cosine of t over 2w. So first thing I need to do is separate the variables. Get the w's and the dw's on one side, the t's and dt's on the other. So I'm just going to multiply the 2w over here and multiply the dt over here. Take the antiderivative of both sides. So what's the antiderivative of 2w dw? What's the antiderivative of 2x? It would be x squared, right?
Yeah. Wait.
So if we've got 2x, I would add 1 to the exponent, and then take the old coefficient over the new
Yeah, I
exponent.
don't know why I was.
So 2 over 2 would just be 1x squared, right? It's the exact same thing here, right? No matter what the variable is, this antiderivative would just be w squared. What about the antiderivative of 3 cosine? 3 sine. So 3 sine of t plus c. Then we want to use our initial condition. At t equals 0, the temperature is 3. So I'm going to plug 3 in for w and 0 in for t. So we get 9 equals 3. What's the sign of 0? 0, right? The y value at 0 is 0. So we just get that c is equal to 9. So, solving this then, we get w squared equals 3 sine of t plus 9. To solve, we would just take the square root, right? And get w equals the sine of t plus 9.
I should have stayed in the office. What is this? Oh, they're all gone.
They're all gone.
You're still teaching?
Make a video and send it to them. So we get the square root of 3 sine of t plus 9. Right? Now, technically, we would only have the positive square root because our initial condition, if we plug in 0, we get a positive value out. So we would not put plus or minus here for our final answer. It would only be the positive root. Okay? That work right there is worth 5 points. Okay? Why would we get
I'll be honest. I'm just trying to get more work. Yeah, I'm worried about this career. I'm literally worried about.
Did you know like last week was 8
Didn't know that.
Okay, well.
Thanks. We're doing the one differential equation that we didn't get to yesterday because it looks a little bit different than ones that we have done before. It's just in terms of w and t instead of x and y. So it looks a little bit different, but it's still the exact same process, right? Separate the variables, take the antiderivative of both sides, plug in your initial condition to solve for c, plug your c in, and then solve for w in this case instead of y. So what don't you think you can do
You
on
should
that?
never know if that's the question to ask me. Yeah, that's pretty much it. Like I could easily just do this when you're like, are you gonna judge me if I get a 1?
No.
I get it.
I
one.
know,
Like,
I
there's 1. I might. Okay, I was 1 for
No,
that.
it's
So I
just-
could get a 2.
I've accepted it. So
I
I'm
was
gonna
gonna
be
not
upset.
getting.
I know.
accept it.
No, but I'm not gonna be upset if it happens because I know.
Oh yeah.
That I know.
So like if I get better, then I'm gonna get excited. Or if I think I'm gonna do good, I do bad, then I'll be disappointed.
Like there's no chance of me getting higher than
I will literally
That's
be happy if I
not
get a 2.
true.
No, it's okay. Like it's I'm not mad.
I was 1 point off from a 2. I'll be happy if I get a 2. I'll be happy if I. But that's just because I guessed really good on those. Well,
Instead of
I had to guess really good because there's no way I got 4.
instead of accidentally showing a plate, I got to show.
I'm not do that.
Yeah, don't
Or just not show up.
But I don't have to take it.
Yeah.
Yeah, Dinah has to take her in the big record.
Not the calc one, the government
Once
one.
we take the test, it's over.
Yes.
And we never have to talk about anything ever again. That is true. Until we got scores.
That's gonna ruin my summer. I'm gonna text back on my mind.
That's how I get one.
Don't really ruin my
Yeah, I probably won't delete it until the beginning of next school year.
So real. Just kidding.
So, guys can't get a 3.
Those 3 over there might be. Dinah for sure. Nicole, Megan might. Megan might. It depends on the day.
You can as well.
Have you not noticed? It's literally like this.
It's more because they pay attention. He is on her phone. I pay attention to Mia on her phone.
I pay attention when going out in the real world. Because this is not real world.
I try to pay attention.
I really try hard, but it's so hard to
It's
like.
a lie.
No, I really try hard to do it, and then I'm just like, I look away for 10 seconds, and I pull it off.
Okay, so then
I
you
get
get
back
on
up.
her phone.
So don't move away for 10 seconds.
You know, I try.
I was watching the Ed puzzle, like doing the problem. I literally, someone asked me, someone asked me a question, I like answered it, and I turned back, I'm like, what? I have no idea what the heck this means.
That's the whole. The video you can like go back.
No one wants to go back on 45 minutes.
Hey, that was a long one, I know. Alright, so the 6 types of free response questions that we've already looked at, are the most common 6 types. Okay? Look over those 6 types as we prepare for the test on Tuesday. Today we're going to do the final 2 types, which are a little less common. Okay? We've already looked at several examples of this first type, implicitly defined functions. Okay, so again, I'm not going to read through all of this stuff here. Okay, we're just going to go ahead and jump into the first problem. So we looked at actually a decent number of these types of problems when we did implicit differentiation. Okay, so given a function that's in terms of x's and y's, part A is usually find the derivative, right? Find dy dx. And a lot of times they even give you the answer. Okay, you just have to provide the work to get to the answer. So whenever we're taking a derivative of a function like this, we take the derivative of everything as we normally would. So the derivative of x squared is 2x, derivative of 2x is 2, derivative of y to the 4th would be 4y cubed. But then whenever I take the derivative of something that has a y in it, I have to tack on a dy dx. Right? That's chain rule. Multiplying by the derivative of the inside. So then the derivative of 4y would be 4 dy dx. And the derivative of 5 is 0. So once we get to this point, I want to get all my dy dx's on one side and everything else on the other. So I'm just going to take my 2x and my 2 over to the right side. So I'll have 4y cubed dx plus 4 dy dx equals negative 2x minus 2. Now, I can factor a dy dx out of both terms on the left side. And then just divide by 4y cubed plus 4. So we get dy dx equals negative 2x minus 2 over 4y cubed plus 4. Now that's not quite what the answer looks like yet. Okay, so we do need to take this one step further to make it look exactly like what they have. Okay, so to do that, I could take a negative 2 out of both terms in the numerator, right, and make this negative 2 times x plus 1. And then I could take a 4 out of both terms in the denominator, make this 4 times y cubed plus 1. And then I can reduce this negative 2 over 4. Let's make this negative 1 times x plus 1 over 2 times y cubed plus 1. Okay, so we do want to make it look exactly like what they have. Okay with that part? Alright, so part B then just says write an equation for the tangent line. Well, we need 2 things. We need a point and the slope. We already have the entire coordinate point, so all I need to do to get the slope is plug negative 2 in for x and 1 in for y into the derivative. So, say dy dx at negative 2, 1 be negative 2 plus 1 over 2 times 1 cubed plus 1. So what do we get? Negative 2 plus 1 is negative 1 times a negative would be a positive 1 over 1 plus 1 is 1, or is 2 times 2 is 4. So 1/4. So I've got a point of negative 2, 1, and a slope of 1/4. My tangent line then is y minus y1 equals m times x minus x1. So that would be a plus 2 since it would be a double negative. Now, technically, we wouldn't even have to do this arithmetic. I could just write all of this right here for the slope. Okay? You don't even have to do that much arithmetic. Okay? So if you feel like you would mess that up, just don't do it. Take that and put that here for the slope. That's part B. Questions on that? All right. Then C, find the coordinates of the 2 points on the curve where the line tangent to the curve is vertical. So I want to find places where the slope is undefined. Okay? If the tangent line is vertical, that means the slope is undefined. So if I'm looking at my dy dx, the slope would be undefined wherever the derivative is equal, or I'm sorry, wherever the denominator of the derivative is equal to 0. So to find this, I want to say 2 times y cubed plus 1 equals 0. I'm just setting the denominator equal to 0. Well, divide by 2, subtract the 1 over. So I've got y cubed equals -1. If I take the cubed root of both sides, the cubed root of -1 is just -1. Right? It's not positive or -1, it's just -1. So now, if I know the y coordinate of a point, how would I find the x coordinate?
Because I walked in, it was windy.
What? I
just walked in too. It is so empty today.
Oh, before you got here with me and Jacob.
Yeah, Sharon got me late too.
Okay, I said it as part of that.
Sharon didn't have an excuse. Alright, so if I have my y coordinate of -1, to find the x coordinates that go along with that, what would I do? If I know half of a coordinate, plug it into what?
I don't even know where we're at.
The original.
Which one? The derivative or the original? The original, right? To find actual coordinate points, I would plug that into the original function. So I'm going to plug in -1 for y up here. So x squared plus 2x plus -1 to the 4th plus 4 times -1 equals 5.
What are you?
We're on C. So we get x squared plus 2x. -1 to the 4th would be +1. 4 times -1 would be -4. So x squared plus 2x. 1 minus 4 would be -3. Then I can subtract this 5 over. Get x squared plus 2x minus 8 equals 0. So I want to solve this quadratic, right? This does factor. If I'm looking for two numbers that multiply to -8, that add to +2, +4 and -2 would work. So that would give me -4 and +2. So what that means is the 2 points, and they even told us we should get 2 answers. Right? The 2 coordinate points where the line tangent to the curve is vertical are -4, -1, and 2, -1. -4, -1, and 2, -1. You okay with that one? Take them to the scrapyard. Alright, so the last part, is it possible for this curve to have a horizontal tangent at points where it intersects the x-axis? What does horizontal tangent mean?
The y-axis.
What's 0? The slope is 0. Okay, so this tells me I want dy dx to be equal to 0. I've given another piece of information. What do I know about something intersecting the x-axis? So we're saying the original curve. So is it possible for this curve, meaning the original curve, to have a horizontal tangent, meaning the derivative of the original curve would be 0, where it intersects the x-axis? So what happens when a function intersects the x-axis? A 0 is created, meaning that y would be equal to 0. So that's true wherever the derivative intersects the x-axis. But here we're saying the original curve intersects the x-axis. So we've got two pieces of information here. The derivative equals 0 and y equals 0 in the original function. So let's take this dy dx and set it equal to 0. So 0 equals negative x plus, so negatives on the outside, negative x plus 1 over 2 times y cubed plus 1. So to solve something like this, I would multiply the denominator by both sides. So that ends up canceling out, right? Because 0 times the denominator is just 0. So we get, I'm going to go ahead and distribute that negative sign through. So add the x over, and we just get x would be equal to negative 1. So what we can do is say, well, I can plug negative 1 in for x and 0 in for y into my original function and see what happens. So negative 1 squared plus 2 times negative 1 plus 0 to the 4th plus 4 times 0 equals 5. So negative 1 squared would be positive 1 minus 2 plus 0 plus 0. So we get negative 1 equals 5. That's obviously not true, right? That is not a true statement. So to answer the question, is this possible? Well, no, it's not. Right? We can't have a horizontal tangent where we intersect the x-axis because we get an untrue statement when we take those two things into account. Okay. Questions on that one? You were good on A and B? So if we look at the scoring breakdown on the next page, you would have gotten 4 points for parts A and B.
How far away is Hershey, Pennsylvania? It's like 2.5 hours.
Is that it? I would have guessed like 4. It's
I
only
don't
2.5.
know.
I thought I remember when I was younger, but
When is it? August 31st.
that's the
first.
That's the one in Hershey.
Oh, it's 5 hours 16 minutes.
Pittsburgh
Oh,
is
never
September
mind.
3rd. Columbus is September 5th. But Columbus is really expensive.
I'll go if there's like a New York one.
There's a Buffalo one. Where is Nashville at?
Tennessee.
How far away?
I
7,
was
8
gonna
hours.
punch you if you really did it.
So if you got 4 points on every free response question, you would pass the AP test.
I got people.
Okay, but you didn't have to like do the practice.
No, I was actually trying. Like, I didn't want to embarrass myself, and I still did.
But we hadn't done any review at that point. So what you just told me is you felt pretty confident when we just did parts A and B here.
The fact is different when you're standing in
Yeah.
North Carolina.
Should I come stand in front of you while you take the test?
Oh.
If you go teach it, that'd be great.
Well, obviously I can't teach it while you're taking the test. Alright, so since there are a fewer number of these types of questions that we're looking at today, we're just going to do one example of each. So the final type that we're going to look at is related rates. And I mentioned earlier that the first 6 types that we looked at are the most common types that show up. The 2 that we're looking at today are a little less common.
So is tomorrow just an overall review?
Yeah.
And are you collecting a pair and you want us to bring in our books tomorrow morning? Or
You can just bring them on Monday. Wait, I thought you weren't going to be here Monday.
But I can drop it off Monday morning.
Okay.
Because I think graduation starts.
Are you just using your books? Just leaving your locker.
Yeah, but then I can work on it over the weekend.
Oh, man, there's one in North Carolina. Where's Rayland, North Carolina?
Raleigh.
It's like 7 hours. 7 or 8. It's only 2 hours from my campus, so let's just go to Miami.
That's close.
Yeah, that's the closest one.
All right, so the final type that we're going to look at is related rates. Right? The key to a related rates problem is whenever you see something that says with respect to time. If you see with respect to time, that's generally going to be a related rates problem. So this problem here was on the 2016 test. Right? Everybody freaked out about this one. They thought this was the hardest question ever. Right?
You have to do like the triangle thing.
No, you don't.
Two triangles,
What is
that?
The RH
The-
equal?
She's talking about when we did cones and we had to set up similar right triangles and take the volume of a cone and put it in terms of the single variable. Look like a deer in the headlight now. Alright, so this problem says the inside of a funnel of height 10 inches has circular cross sections as shown in the figure above. So this isn't a cone. Okay, it's some weird shaped funnel. The height, or at height h, the radius is given by this equation here. Okay, so all this equation models is the radius of this funnel. We're in inches. So part A, we want to find the average value of the radius of the funnel. How do I find average value?
1 over
Here we go. So we're going to say, and they tell us our bounds, right? Our bounds here are in terms of h. Okay, so my integral isn't going to be from 0 to 10. How would I find what my integral should actually be?
good question.
So if we have a function for r,
Don't you just grab it?
oh, wait a minute, sorry, I said that backwards. I was thinking this was r. No, we've got r equals this function, so our bounds would be 0 to 10. This is like our x value, and r is like our y value here. Right, so we would set this up as the integral from 0 to 10 of 1 over 10 minus 0 of our function. Right, just 3 plus h squared. This was not a calculator question. So we could pull this 1/20th out, right? And say 1/10 times 1/20th would just be 1 over 200 times the integral from 0 to 10 of 3 plus h squared dh. So then how would I take the antiderivative of each piece here? What's the antiderivative of 3x, or in terms of this problem, 3h. And then the antiderivative of h squared, that would be the derivative,
Oh,
1/3 h cubed. So I'm evaluating this from 0 to 10. So obviously if I plug in 0, everything's going to be 0. So really all I need to do is plug in 10. So 1 over 200 times 3 times 10 plus 1/3 times 10 cubed. That's it. Do not do the arithmetic. Right? So what would my units be here? Inches. Okay. this would be the average value of the radius. So this is just in inches, not plants. Please don't write plants every time on the AP test. I feel like you would do that just to try to be funny.
No one else is gonna read my test but the person on screen. They're gonna think I'm stupid.
Right, but I feel like you would do it just to entertain yourself.
Just to be able to come into class and be like, hey, guess what happened?
Yeah.
You know what? You guys always see I'm gonna bust up laughing like nothing's be happening. Dude, really? I was so confused in the practice test because like, I'm sitting there not on my phone. So I look over, Morgan's on her phone, Mia's on her. I was like, I didn't know we were. Well, when I went to the English one, people were on the phone like after we were done. So I just assumed she wouldn't hear us. So I was just like, maybe we shouldn't have had her. We were definitely entertaining each other. Applesauce. Seasoned applesauce. There's nonsense. Is it? Give me a seasoned applesauce.
Seasoned.
I mean, technically that's not wrong.
Yeah, yeah, but I don't want to use apple. Give me an apple.
Alright. Part B. Find the volume of the funnel. If I'm given a function that models the radius of a cross-section, how do I find the volume?
You have to set it up like a circle.
Yeah.
Area.
Antiderivative.
Yeah, that's it.
Yeah, so we've got a function that models the radius of a cross-section. So I want to find a function that models the area of a cross-section. So I'm going to say a of h is going to be pi times the radius squared. So pi times this function squared. 1/20th times 3 plus h squared squared. So I want to take the antiderivative of this. Same bounds, right? 0 to 10. I can pull my pi out. So 1/20th times 3 plus h squared squared dh. Don't forget your dh. Okay, I still see that being left off paper sometimes. There is not. I mean, there you can find. Remember, we talked about you can find the antiderivative at a specific point using Math 9. Right? So that's just area under a curve. So I mean, I guess you could evaluate this, okay, because it has bounds on your calculator, but this was on the non-calculator part of the test. So to do this, the easiest thing to do would probably be to go ahead and square everything on the inside, and then take the antiderivative piece by piece. Right? So if I square everything, let's see, 1/20th squared would be 1/400, and then 3 plus h squared squared would be 9 plus 2 times the product of the 2, 6h squared plus h to the 4th dh. So I could even pull that 1/400th out front. Okay, I'll go ahead and do that and just write this as pi over 400. And I'm just taking the antiderivative of each of these pieces. So we'll have pi over 400 times the antiderivative of 9 would be 9h. Antiderivative of 6h squared, I would add 1 to the exponent, and then take the old coefficient over the new exponent. So 6/3 would be 2. And then have 1/5 h to the 5th, evaluating that from 0 to 10. So again, if we plug in 0, all of this would just be equal to 0. So all I have to worry about is plugging in 10. So pi over 400 times times 10 plus 2 times 10 cubed plus 1/5 times 10 to the 5th. And we're done. Do not do the arithmetic. We would want to tack on units, though. So if we're talking about the volume, what would my units be? Inches cubed, yeah. Okay, so now it's actually not until part C on this problem that we run into related rates. Okay, this one was multiple different ideas, right? Average value, volume, and related rates combined into a single problem. So C says the funnel contains liquid that is draining from the bottom. At the instant when the height is 3 inches, the radius of the surface is decreasing at a rate of 1/5 of an inch per second. At this instant, what is the rate of change of the height with respect to time? So whenever we see with respect to time, and things are decreasing at a rate, we should think related rates. So I'm given this function, right? My R equals, and I'm going to go ahead and distribute that 1/20th. So 1/20th times 3 would be 3/20ths plus 1/20th h squared. So I want to take the derivative of this function with respect to time. What that means is whenever I take the derivative of any variable, I have to tack on a d whatever dt. So when I take the derivative of r, that will be dr dt. Well, the derivative of 3/20, that's just a number, would be 0. Then here, derivative of 1/20th h squared, bring the 2 out front, so 2/20 would just be 1/10 h dh dt. Now let's take a look at the information that we're given. Okay, I'm told h equals 3, and the radius is decreasing at a rate of 1/5. So I'm going to plug in 3 for h, and dr dt is going to be negative 1/5. Okay, the rate at which the radius is changing. So that'll be negative 1/5 equals 1/10 times 3 times dh dt. So now I just need to solve for dh dt. Okay. So negative 1/5 equals 3/10 dh dt. To get rid of the 3/10, I would multiply both sides by 10/3. So times 10/3 times 10/3. And we get negative 10/15 equals dh dt. Okay, we would want to tack on units. So what would my units be for the rate of change of the height? Inches per second. Obviously, we could reduce this, but don't try to reduce it, right? Just leave it as negative 10/15. Okay, so the related rates part of this question actually wasn't that bad. We didn't have to do anything like similar triangles. We didn't have to solve for any missing pieces. All we had to do was take the derivative and plug in what we knew. Okay. Questions?